Next is question number 71, which says that if the line m square minus 1 into x plus m square plus 1 into y minus m into m minus 7 equal to 0 is normal to the circle x square plus y square minus 4x plus 6y plus 12 equal to 0, then the sum of all possible values of m is. Now, we know that any line which is a normal to the circle will pass through the center of the circle. So let us firstly find the center of the circle, that is dividing the coefficient of x by minus 2 and the coefficient of y by minus 2, we will get 2 comma minus 3 as the center of the circle. So this point will satisfy this line. So we can say that m square minus 1 into 2 plus m square plus 1 into y, that is minus 3 minus m into m minus 7 is equal to 0. So solving this further, we get that 2m square minus 2 minus 3m square minus 3 minus m square plus 7m is equal to 0. So we can say that minus 2 times m square plus 7m minus 5 is equal to 0. That is 2m square minus 7m plus 5 is equal to 0. So we can say that one of the possible value is 1. So it can be written as m minus 1 into 2m minus 5 equal to 0. Hence, the possible values of m are 1, 5 by 2. So the sum of all possible values of m is 1 plus 5 by 2, that is 7 by 2. So the correct answer will be option number 3. Next is question number 72, which says that the tangent to the ellipse x square upon a square plus y square upon b square equal to 1 at any point intersects the coordinate x's at points a and b. The equation of the locus of the midpoint of AB is. So let us say this is the coordinate x's and this is the ellipse x square upon a square plus y square upon b square equal to 1, where it is cutting x-axis at a comma 0 and it is cutting y-axis at 0 comma b. So we have a tangent here which intersects the coordinate x's at a and b. So we have to find the equation of the locus of the midpoint of AB. Now the equation of tangent on ellipse, let us say this point is a cos theta and b sin theta. So the equation of tangent on this point will be x upon a into cos theta plus y upon b into sin theta is equal to 1. This is the equation of the tangent. So we can find the coordinate a as putting y equal to 0. We will get a into secant theta comma 0 and the coordinate b will be equal to 0 comma b into cosecant theta, right? So these are the points a and b. Now we have to find the equation of the locus of the midpoint of AB. Let us say the midpoint of AB is h comma k. So h will be equal to a secant theta plus 0 upon 2 and k will be equal to 0 plus b into cosecant theta upon 2. That is cos theta is equal to a upon 2h and sin theta is equal to b upon 2k. Now we know the identity that cos square theta plus sin square theta is equal to 1. So we can say that a square upon 4h square plus b square upon 4k square is equal to 1. That is the locus is a square upon x square plus b square upon y square equal to 4. Substituting h equal to x and k equal to y. So the correct answer will be option number 2. Next is question number 73, which says that if the vertex and the focus of a parabola are minus 1, minus 3 and 0, 2 respectively, then the equation of the directrix is. So let us say this is the parabola and the vertex of the parabola is minus 1, minus 3 and the focus of the parabola is 0, 2. Now we have to find the equation of the directrix. Let us say this is the directrix L1 right? So let us say directrix is cutting the axis of the parabola at M. Let us say this point is O and this is A. Now we know that O will be midpoint of AM. Let us say the point M is h comma k. So we can say that h plus 0 upon 2 is equal to minus 1 and k plus 2 upon 2 is equal to minus 3. So the coordinate h comma k will be equal to minus 2 comma minus 6 minus 2, that is minus 8. Also we know the slope of line L2, that is the axis of the parabola, is slope of L2 is equal to 2 minus minus 3, that is 5 upon 0 minus minus 1, that is 1. So slope of line L2 is 5. So we can say that slope of line L1 will be equal to minus 1 upon 5. Now the equation of the directrix will be equal to y minus y1, that is minus 8, equal to m, that is minus 1 by 5, into x minus minus 2, that is x plus 2. So the equation of the directrix is 5y plus 40 plus x plus 2 equal to 0, that is x plus 5y plus 42 equal to 0. That is the correct answer is option number 4. Next is question number 74, which says that the eccentricity of the hyperbola passing through the origin and whose asymptotes are given by straight lines y equal to 3x minus 1 and x plus 3y equal to 3 is, that is, this can be written as 3x minus y equal to 1 and this is x plus 3y equal to 3. Now here we can say that slope of this line M is equal to minus 3 upon minus 1, that is 3, and slope of this line M2 is equal to minus 1 upon 3. So here we can observe that the two lines are perpendicular to each other, that is asymptotes are perpendicular to each other. So we can say that the given hyperbola should be a rectangular hyperbola, and for rectangular hyperbola we know that the eccentricity is equal to under root 2. So the correct answer will be option number 1. Next is question number 75, that is tangent to the parabola y square equal to 4x at any point P on it intersects its directrix at a point T. The orthocenter of triangle PTS lies on its, where S is the focus of the parabola y square equal to 4x. Let us say this is the parabola y square equal to 4x and it is given that tangent to the parabola intersects the directrix at point T. This is the directrix. The orthocenter of the triangle PTS is where S is the focus and this is the point P. Now we know the property that if we draw a tangent on a parabola at a point P and if it intersects the directrix at a point T, then PT will subtend a right angle at focus of the parabola. So this angle is 90 degrees. Now the orthocenter of triangle PTS is S itself, right? Now we know that focus lies on the latest rectum of the parabola. Hence we can say that the orthocenter of triangle is lying on the latest rectum of the parabola.